Hey there, friends. Welcome to another adventure of Blink. So, today we're going to talk about AI. Unless you've been living under a rock for the past couple of years, you've probably seen that AI has taken the tech industry by storm. Everything has to have an AI component in it now. Everybody's exploring and experimenting, and there's new things popping onto the market constantly. And we've all been chat GPT'd to death, and it's going to take all our jobs, and we're all panicking. I don't believe the panic is necessarily warranted. There may be some places that we should be concerned, of course, but I don't think widespread panic is really the right answer to that. So today we're going to look at a thing you can build for free very quickly in Python to recognize your face. We'll also talk a little bit about how machine learning actually works and sort of give you a base understanding there so that as you're exploring it, it might make a little better sense the further you go. First, let's talk about vectors. A vector is just what you remember it is from math class.
It's a mathematical term, a quantity represented by an arrow with both direction and magnitude.
In machine learning, vectors are used to store data in a way that a computer can begin to semantically understand. That is, it doesn't just know about the data it was given, but it can start to infer relationships between data based on their proximity to each other in these vectors. This is really valuable because it's a representation of how humans actually process data in our brains. Sometimes we can see parallels that aren't directly noted in the data because we sort of do a pattern matching thing with it, right? Your brain can do that, but it's really hard to think about how you would teach a computer to do that. So, in order to recognize a face, your computer needs to be able to understand what a face is, but it can only understand it as numeric data. To facilitate this, folks have written code that turns inputs into something called embeddings. An embedding is just a vector representation of the data that's been input. So let's talk about image comparisons. If I'm taking an image and trying to figure out if it's similar to another, in traditional code, I've probably only got one possibility, and that's exact match. The fun part about exact match is it can't exist in the real world. If I took two photographs, even of the same object from the same angle, from the same distance, and tried to control as many variables as possible, the two images are still going to have variations in their data. That's just a fact of life. So the only way I'm going to be able to tell if they're the same thing is if I can get a similarity sort of comparison. Traditional code can't give me that. The only way I can get to it is to run through a machine learning algorithm, a model that's been trained on thousands of images of this type of thing to be able to detect, oh, look, these are the patterns that match that. That sounds all really complicated and wild, doesn't it? So here's the good news. You don't have to build a model today. Building a model is expensive and time consuming and complicated. But once it's been built, as long as you have the right kinds of inputs to put into that model, you can use it for anything and everything. It's completely reusable. So that's what we're going to do today. Let's go over to our dev environment and see if we can get started on making some magic, shall we? Okay, so let's head into our editor. You can see here I've got an empty main.py ready to go. But I'm going to start by creating a virtual environment. So Python 3, and we'll do this. Yes, we want to use it. So the next thing we're going to do is source, and we'll do then bin activate, and we are ready to get started with our coding. Now there's one file we're actually going to need before we do anything with the code, and that's a reference image of the person that we want to capture. So of course I'm using yours truly. If you'll give me just a moment here, I will drop this in, and you can see, hey, there's a great picture of me. You'll also notice that had a gray background. It does not really matter. I did like a gradient background because I was trying to do something that would be different from the actual background that I have here during the show. So there's your difference to keep in mind, that this image is actually very different, numerically speaking, from the image that it will be taking from the webcam in order to make the comparison. All right, so let's see if we can get started with our code. Oh, actually, we need to pull in a couple of things. So we'll start just by doing our imports. So in order to make this work, we're going to use threading, because we're going to have a multi-threaded approach to it. Every time that we want to analyze an image, we're not going to make the whole application stop. We're going to throw off a thread to do that analysis and send us back the results. The other thing we want to bring in is CV2, because we want to be able to access our camera. And then from DeepFace, import DeepFace, just like that. And of course, you'll see these are not showing up because we actually need to come down here and do pip install OpenCV Python and DeepFace. And we'll let that run for a little bit here. Short version is it's going to go grab a whole bunch of library things that handle. So CV2 is being called from OpenCV, which gives you access to your camera video controls. And then DeepFace is the machine learning model that we're going to be using to do the facial comparisons. So you need both of those, one to access the image input and the other as a way to be able to analyze the data as it flies. So there we go. We've finished our imports. Now let's see what we can do next. First thing we need to do is open a video capture. So I'm going to call that cap, and I'm going to do cv2.video. Oop, I tabbed too fast. It's video capture. And here you would actually put a number that represents which video device you're using. So for my case, I'm just using video capture 0. So the next thing we're going to do is set a couple of values in the video capture settings. So I'm going to do cv2.cap prop frame width, and we're going to set that to 640, and cap.set, and then I'm going to come up here and grab the same thing and drop it down here, except I'm changing this part to height, and I'm going to change this to 480, just to make a small. This is your video frame that's going to appear with the video capture from your camera. Next thing we need is a counter, because we're going to be only doing this on certain frames. Obviously, your computer can process a lot more frames of data than you can personally. And so if it's running at 60 frames a second, you don't want 60 analysis threads being kicked off every second. That's going to be way too much for what you want to get done. So it's up to us to figure out what the pattern there will be. We can do that later. The short version is you have to have the counter there in place to know which frame you're on, so that you can do like a modulus operation and find it. So the next thing we want to build is a variable where we're going to hold the results. We're going to do it out here because we want it to be global to the program. Obviously, there will be some other things thrown around here along the way, but we needed to make sure that was out here. Then we're going to specify which model we want to work with. So we're going to create something, model equals deepface.build model, and we're going to use one that you can find in their documents is called FaceNet. Then we're going to do a reference image. And so I'm just going to make a variable here called reference image, and in that I'm going to do an imread, and because it's in the same folder here, I can just do the name exactly as it's written up there. I'm really bad at typing today. But that is our reference image. So, just so that we can keep track of where we are, I'm a big fan of having print statements along the way, and we will say reference image has been loaded. That could come in handy later if we have to debug if something goes wrong. Now, the next thing we're going to have in here is the actual method that's going to check the face, but we're not going to write it immediately. We're just going to leave it here as a placeholder and go through the rest of the main logic. So I'm going to just do a def for check face, and we're going to pass it a frame. And so for now, I'm just going to do pass. We'll come back and fill this method in later. The next thing we want to build is an infinite while loop, because we're going to stay inside this method, in this loop, until we tell it to break out and quit the program. So while we're in here, we're going to get two values passed to us. Equals cap.read. If you look at the read methods, return information there, it sends back two values. RET, the first thing we're catching, is just a Boolean to tell us whether the data payload is useful data or like empty. It's always going to return data from the method, and the question is this an actual frame, or did something go wrong? So if RET is true, then that means we successfully captured this frame. If not, cap dot is opened. It's always important to check. Oh, you know what? I might have done those out of order, but I think it'll work still. We'll throw that in there just as a way to do it. And then that will break us out of the loop. So if the webcam isn't working for some reason, then we want to know about it immediately and fail everything because, hey, this isn't working the way we expected. Now, so we're going to come in here and do this, and we're going to check whether we are on a frame that we want to process. So if the counter modulus 30 equals 0, then we need to try. We'll start with a print statement to let us know where we got to, creating thread to verify image. And then we will do threading dot thread. The target we will pass in is check face. So we're creating a new thread that calls that method we made back up on line 20, check face. And the arguments we're going to pass frame.copy. You don't pass the actual frame here. That could be scary because then you would have all these threads competing over that actual space in memory, and if it makes any alterations, then the program crashes. So we're going to make a copy of the frame to pass into the thread so that it can process. And then another little wild thing, this args is expecting a tuple, and we can't do this by itself to have a tuple because there's one object and we're not going to have multiples. So, little Python trick for you. If you just add a comma there, then you are set. That will create a tuple. And after we have created this thread, we will start it. Now, except, oops, I didn't need the colon yet. I need to do a value error. So if we get a value error from this thread creation. We are just going to ignore it. We're going to let this roll past. And the idea here is if you happen to get one that hiccuped along the way, it will just be picked up on the next set of frames, and so you don't have to worry about it too much. If there's something larger at work that needs to be addressed, then of course the program may crash. But for something like this, it'll probably be okay. So after we've done that, we are going to increment our counter. And the next step is to check to see if we got a match. So if face match is true. Now face match, you remember we declared outside of the loop. It's way back up here, line 13. The reason we did that is that it will make it global for us to pull this in and out of the method. The method will actually update face match when we write it. So let's assume for the moment that it's worked, and so we have a match. What we're going to do is tell the camera object on our screen to add some text. So we're going to add it to the frame, and we're going to make it say match, because we're excited about that. Now we have to specify the location, and so we're going to say 2450, and then we're going to go pick a font. So we're going to use Hershey Simplex, something standard, nice and easy to grab at. Okay, now we need to specify the color. So you are probably thinking of this as RGB, and you would be mistaken because this is BGR. This particular method uses blue, green, red, not the standard that we're all used to of red, green, blue. So for the green, it actually doesn't make a difference because it's the middle one. And then you have to specify the thickness, and so we'll do that. And I made that statement about the colors because on the next one, we're actually going to just copy this whole line. And on this line, the only thing we're going to change is that it will say no match. And we're going to change the 255 to 0, but we want red. So if it's BGR, then R is the last one, and we have to put the 255 in the last spot in the color. All right, so now that's done. The next thing we're going to do is actually show, and this is just the window title, so I'm going to do webcam video, and we're going to show the frame. Now, the next thing we need is a way to get out of the loop. So we're going to create a key, which is cv2.wait key, and we'll wait for a 1. If key equals the ordinal for Q, then we will break. My JavaScript, or JavaScript, all of those where I want to end with a semicolon. It's just programmed into me. All right, the very last thing we need, once all of this is complete and we're out of the loop, that means we're done with the program. And so we are going to clean up after ourselves by doing a destroy all windows. So now that we've finished all of the basic logic for how this is going to work, we actually need to go implement the method that's going to do the facial recognition analysis. So that's back up here on line 20. There's check face, right? We're going to take this pass out, and instead we're going to put a global face match because we want to make sure it knows it can use that variable elsewhere. All right. And then we're going to do this inside of an error handling block. So the first thing we need to do is pre-process our image. We want to have that in the proper format so that it can be used. by the analysis comparison, and things should line up well. So I'm going to make a variable here, and we're going to change. Remember, we talked about it being BGR below. We're going to actually convert it to RGB. So CV2 CVT color. We're going to use the frame as the input, and we are going to do color dot, or not dot, underscore BGR to RGB. And that should pre-process the frame. Now the next thing we're going to do is get a result from DeepFace. So we're going to go to DeepFace and we're going to ask it to verify, and we're going to pass in first the frame and second the reference image. And then we're going to do the model name, which this may be overkill because I think we declared the model up top, but just in case, FaceNet, it doesn't hurt to declare yourself. All right, so that's the result that comes back from verify, and what we're going to do is set face match equal to the result, and we want to look for the property that says verified in it. That will tell us whether it found a match or not. Now we had a try, so we need to do an accept and a value error here. So if this comes back in any form that doesn't make sense to us, then we declare that the face match is false. By default it was false, but we're just going to explicitly say that there because we want to ensure that face match is false if we don't get back a value that makes any sense. So now I think we might actually be ready to run this sucker. Let's see if we can make this work. So I'm going to come down here and I'm going to do Python 3 main.py. And it has started up. Let me bring it onto the screen here where you can see, and you can see it's matching my face. Remember, my face is the reference image. So just for giggles here, let me see if I can find something to put up in front of my face. Here's a notepad. And if I block my face, I can see it instantly goes to no match. So you can play around with this a little bit and you can see some other options. For instance, if I turn my face too far, then I get a no match. The model only recognizes the face as it's full on directly facing the camera. So that's a limitation there. You're not getting the entire training of the face. You might be able to pass in other inputs from different angles if you wanted this to match as well. But it's expecting you to be looking at the camera in order to validate your face. So there's that. We can also try other faces. So if I look back here on my bookshelf, I happen to have a copy of Return of the King, as every good Tolkien fan should. And if I put Viggo Mortensen up there, it knows that Viggo Mortensen is not Blink. Pretty cool, huh? So there you have it. In just a few lines of Python, you can build a facial recognition app. Stop by my GitHub. Pick up a copy of the code, try it out yourself, see if you can make something interesting happen with it. And then tag me. I'd love to hear what it is you've built off of this. So can't wait to see what it is you actually bring back to the table too. We'll see you next time on the Adventures of Blink. Happy coding. Ooh, I needed to pop back in here for just a second because I forgot about something. I ran into this when I was originally testing, and then when I went to set it up, I completely forgot. So naughty me for not taking notes. But you may run into a TensorFlow error when you try to run this the first time, if you've been following my process exactly, and that's because a package is missing that you need to add. So you can see there is the name of the package, and I'm just going to pop right in here and do pip install tfkeras and let it run, and that will take care of this problem. So don't forget all of your imports.